In this video, we are going to be applying the different properties that we just learned on the quadrilateral flowchart to some actual examples. So I would have your flowchart out in front of you so that you can kind of use it to help you find missing sides or angles in the different shapes. So the first example is a kite. So I always like to start by labeling everything I know about a kite. So I'm going to use my flowchart and the tick marks to label some things. So in a kite, I know that the two pairs of disjoint consecutive sides are congruent. So I know that AB and BC would be congruent. Therefore, BC would also be equal to 5. And then I also know that AD and CD would be congruent. So those would both be 9. I know the diagonals of a kite are perpendicular, so they would form 4 right angles in the middle. And then I also know that they have 2 pairs of opposite angles that are congruent. So that would be angle BAD and angle BCD. And then the 2 angles that are not congruent, I know that they are bisected. So if the bottom one is 40, the one next to it would also have to be 40 degrees. And if the top one is 60, then the one next to it would be 60. Okay, so now that I have everything labeled, let's look to the right-hand side to see what it's asking us to find. So first it asks for angle BEC, and I already have that labeled as a right angle, so that would be 90 degrees. Then it asks for angle BCD. So this one's a little bit trickier. This one you really have to look at on the triangle BCD. So I'm going to highlight that here in blue. And if I highlight that, I know that all the angles in a triangle have to add up to 180. So if this angle's 40 and this angle's 60, that adds to 100. Therefore, that angle would be 80 degrees. So angle BCD would have to be 80 degrees. Then I'm going to look for angle ABE. So ABE, I already have that labeled as 60 degrees. And then the measure of angle ADE, I already have that labeled as 40 degrees. And then we know BC is the same thing as AB, which is 5, and CD is the same thing as AD, which is 9. All right, moving on to the next shape. Again, I'm going to start by labeling it with the given information and then think about what I know about a parallelogram from my flowchart. So it says that BE is 12, so I'm going to label that as 12, and then angle ABC, so this angle here is 140 degrees. So in a parallelogram, I know that opposite angles are congruent, so this would also be 140. I also know that consecutive angles are supplementary. So if that's 140, then each of these angles would have to be 40 degrees because they have to be supplementary to each other. I also know that the diagonals bisect each other, so I know that ED would also be 12. Okay, so it's asking for the measure of angle BAD. So I already have that labeled over here as 40 degrees. And then the entire diagonal BD would just be 12 plus 12, which is 24. Moving on to the next example, a rhombus. So there's a lot we know about a rhombus. We know that all the sides of a rhombus are congruent. So if one side is 14, that makes all sides 14. I also know that the diagonals of a rhombus are perpendicular, so they're going to form 4 right angles. And then I know that in a rhombus, the diagonals bisect the angles. So if that angle's 40, then the one next to it would have to be 40. And same thing with the angle across from it, since opposite angles are congruent. Okay, so now let's look at what we're trying to find. So it asked me to find the measure of angle PTQ, which I already have labeled as 90 degrees. Then it asks for the measure of angle PQS, which I already have labeled as 40 degrees. Then the measure of angle PRS, okay, that one I do not have labeled, but again, I can look for triangles. So I'm going to highlight this small triangle, PTR, and I know that all 3 angles in a triangle have to add up to 180. So 90 plus 40 would equal 130. So then this would have to be 50 degrees, which would make all of these smaller angles 50 since their angles are bisected by the diagonals and then opposite angles are congruent. So the measure of angle PRS would therefore have to be 50 degrees. Then the measure of angle PSQ is 40 degrees. I already have that labeled. And the measure of angle PQR would be this entire angle, 40 plus 40 is 80 degrees. And then QR is the same as PQ since all sides are equal, so that would be 14. Okay, moving on to the next set of examples. Okay, the next one is a square, and this one is the most complex quadrilateral. So we have a lot of things to label. We know that all the sides of a square are congruent, so they would all have to equal 10. I know that all the angles of a square are right angles. I also know that the diagonals of a square bisect the angles, so these would each have to be 45. So lots of 45-degree angles here. And then I also know that the diagonals of a square are perpendicular, so they form 4 right angles in the middle. So the first angle it asks for is angle OLN, and I already have that labeled as 45 degrees. Then the measure of angle NMO is the same, 45 degrees. The measure of angle OLM would be 90 degrees. The measure of angle LTO is also 90 degrees. And then it asks for the perimeter of the square. So for the perimeter, I'm just going to do 4 times 10, which is 40. And then for the area of a square, I just do length times width. So 10 times 10 is 100. We're going to get into more about area in a future chapter, so I wouldn't worry too much about the area. Okay, parallelogram is next. And so I know that opposite angles in a parallelogram are congruent. So my algebra equation would be 4x is equal to 2x plus 50. Then I'm going to solve that for x. So subtract the 2x. I get 2x is equal to 50. So x would equal 25. But the question is asking for angle C. So I know that consecutive angles in a parallelogram are supplementary. So I'm going to find the measure of angle D by doing 4 times 25, which is 100. And I know this angle has to be supplementary to it. So therefore, angle C would have to be 80 degrees. Last example is an isosceles trapezoid, and it gives me some given information. So first it says that segment DB is equal to 17, and the measure of angle ADC is 65 degrees. So in an isosceles trapezoid, we know that the diagonals are congruent. So AC would be the same thing as DB, so that would have to be 17. And we also know that in an isosceles trapezoid that the lower base angles are congruent. So angle BCD would also be 65 degrees. All right, so tomorrow in class, we are going to practice some more examples and applying the different properties of the quadrilaterals. So make sure you have your flow chart. You're really going to need to study that for the next quiz and test.